There was a time when the tools of cinema were shaped by the people who used them. Today, every digital camera you can buy is designed around someone else's idea of what you need. But what if we could take that back? That very question is what first fascinated me about the world of open source cinema cameras. A while back, I made a video about CinePie, an open source SDK that lets you, yes, you, build a cinema camera from off-the-shelf parts, and on top of that, it's shot in 14-bit RAW. Since that first video, I've been thinking about what cinema cameras could really be if it wasn't locked down by a manufacturer. Imagine a camera you could build exactly like a gaming PC. You could pick your sensor, upgrade it later if you want, replace broken parts easily, and every improvement comes from people who actually care about this stuff, not just a team of suits looking for ways to jam generative AI into a camera body. This is my CinePie build. There aren't many like it, and this one is mine. I built it myself with the guidance from the creator of CinePie and using a PDF from a creator who's put a lot of effort into advancing open source cinema cameras in this last year. And for only $375, not including lens, tools, and accessories, and a 3D printer, of course. What excites me most is not just the hardware, though. It's the freedom and potential I have to do whatever I want and tinker and customize my camera because it's my camera, my way. Period. This is the camera I ended up building. It uses a mix of hardware choices from the Cine Eve documentation along with the body from the original 3D printed CinePie V2 because honestly, I really like SchoolPost's original design. Where my build differs is in how I choose to power it. SchoolPost used an internal battery and charging solution, which for a lot of people makes perfect sense. I went a different route, however. I built mine around external NPF plates and batteries, usually used for camcorders, because I want to be able to throw the largest battery I can on this thing and shoot all damn day. This is a big part of what I mean when I say my camera, my way. I took what I liked from existing projects and combined those ideas into something that actually fits how I want to shoot. That makes this project something special. If something breaks or becomes unavailable, you can replace it. If your needs change, you could swap parts and rebuild the camera around them. At the heart of the CinePie-based camera is the Raspberry Pi single board computer. And the reason we use the Raspberry Pi really comes down to how it handles cameras. The Pi gives you access to the camera pipeline in a way that allows you to work directly with raw sensor data, using a standard MIPI camera module connected over an FPC cable. That level of access is critical, because without it, a project like CinePie would be extremely difficult, if not outright impractical, or even impossible on most consumer single board computers. In my case, I'm using the Raspberry Pi 5. I went with the 8 gig model, but there realistically isn't a strong reason you couldn't use a lower memory configuration. Even the 2 gig can technically work. Maybe the 1 gig is pushing it, but we haven't tested that yet. It's definitely a consideration, especially given how affordable RAM options are right now. And if you want to take things even further, you could build around the CM5 compute module and a custom carrier board to slim everything down to really streamline your camera. Okay, so all of this is cool, but what does the camera actually see? Or maybe more importantly, how does it see? There are a number of different sensors you can use with a Raspberry Pi, but one of the easiest ones to get your hands on right now is the IMX477 official HQ camera module. It's widely available, essentially plug and play, and comes built in with a C-mount, which makes it great for adapting lenses. That said, there are some real trade-offs. It's a 12 megapixel Super 8 sensor, and while 4K video is possible, the small sensor limits on things like shallow depth of field at a wider focal length, and you're simply collecting less light overall. This results in an image that's good, but not without compromise. Sharpness can be a little lacking, and depending on what you're going for, it may really need some help to shine. Add some film emulation and suddenly you're looking at a vintage-inspired image that still holds up in resolution, especially when you pair it with period-appropriate glass, like old Bullock Cine lenses. Now, there are other sensor options out there that outperform the 477 in a lot of ways, but they come with a bit more of a learning curve to get up and running. One of the most compelling upgrades is the Sony IMX585 Super 16 sensor. Significantly larger than the 477 with way better low light performance. The catch is availability. Until fairly recently, the only way to get an IMX585 was to take the open source schematics from the Starlight Eye board and have a company like PCBWay or JLC PCB manufacture it for you. That process can get expensive quickly, and it's not exactly beginner friendly if you're not comfortable with board design and assembly. Occasionally, you'll see small batches show up on Will Wang's Tindy shop along with other sensor options like the 1-inch eye or 4/3 eye, but Will is a one-person operation, and those runs tend to sell out fast, sometimes staying out of stock for quite a while. That said, there is another. SOA Enterprises also produces an IMX585 camera board, making this sensor a lot more accessible than it used to be. This board is absolutely usable for a custom cinema camera, however, even though it's missing a few features found on the Starlight Eye board. That said, if all you need is a solid sensor that works, this is still a very, very compelling option. And where things start to become more interesting is when things like the IMX585 became more accessible. This stopped being just a collection of one-off builds and experiments. It opened the door for someone to step back, ask a bigger question. What would an open source cinema camera for normal people look like? That's exactly where the Cine Eve project comes in. Cine Eve isn't just another Cinepi build, it's an attempt to take everything the community has learned over the last few years and turn it into a coherent, standardized open source cinema camera. That means clearly defined hardware, a purpose-built camera body, and software designed from the ground up for people who actually want to shoot, not just develop it. Eve also moves beyond some of the limitations of earlier projects with native support for a larger sensor, like the 585, improved power I/O, and focus on reliability and usability rather than constant tinkering. In other words, this isn't about replacing the DIY spirit that made Cinepi possible, it's about giving that spirit a more solid foundation to stand and build on. And just because the Eve project exists doesn't mean I'll be abandoning my Cinepi camera. If anything, it's the exact opposite. What Eve offers is a lower barrier to entry. It's a camera for people who aren't deeply technical, but still have the tinkerer's mindset and want to build something of their own. One of the biggest differences with the Cine camera software is that it isn't something that's built on top of Cinepi at all, which, with a disclaimer, I don't know if that's the truth anymore because we have the Eve project becoming fully open source. It was going to be a product, but the Elite 16 may still be a product, and we don't know about that. But I will say that we are just getting a better version of the Cine Lite software, and that might be based on Cinepi, and then whatever the Elite was going to be might still have the more secret sauce, which is okay. They do them, and the community can work on this over here. I'm excited either way. I'm excited for both things. Cine has also confirmed that the software does not rely on libcamera. By taking a custom approach to the camera stack, Cine is able to design systems around their own priorities, rather than working within the assumptions of existing APIs, or dealing with the bloat that comes from a full general-purpose Linux environment on a Raspberry Pi 5, which, can be a little rough. That doesn't automatically mean it's better in every case, but it does create room for experimentation and features that are hard to explore within the constraints of the current commercial camera ecosystem. Wink, wink. Was that a Red reference? Yeah, that's a Red reference. Make mods. And yes, I'll be making a full video about the Eve and my experience building it. So if that sounds like something you want to see, go ahead and get subscribed and hit the bell. Now, after showing you my own camera, you might actually be wondering how to get involved and start building and shooting something like this yourself. And the answer is, it depends. Depending on what kind of functionality you expect, you could end up building a camera that looks very different from mine. In my case, I wanted something I could get up and running with minimal setup, time, and minimal friction. That doesn't mean I miss out on some of the more experimental features in other Cinepi forks, but the trade-off is that I can flash an SD card and go shoot. So let's start with the Cine Cam software. The Cine Cam Lite software, to be specific, that's released right now. It's a pre-configured Linux image tool designed to work out of the box with a very straightforward software and hardware setup. The basic hardware stack looks like this: a Raspberry Pi 5, a Pi 5 NVMe hat with an SSD, the Hyperpixel Square touch display, a power board to take in and distribute power to the Pi, and a proper hardware power button so you can safely shut off the system. This gives you a no-frills camera that still has some genuinely nice features. You get a clean, simple, touch-based UI, quick setup, and shooting experience that feels surprisingly camera-like for something this DIY. And then you're gonna go ahead and put it in a case of your choosing. Sky's the limit on this one. Or you could build it out of Legos like me. The software is very alpha. It's essentially what will become the full Cine software, so you shouldn't count out other options, like Cinemate. Cinemate is definitely not one that's trying to hold your hand. Cinemate's ideology seems to be there's an expectation that everything should be configurable on the camera itself. Treats the camera more like a system, one that you configure deliberately, ahead of time, based on how you plan to shoot. That means more time up front. You'll be working with configuration files, understanding how the sensor is being driven, how the image pipeline is set up, and how recording is handled. It's not difficult, but it's involved. And That's kind of the point, because once you've put in the work, Cinemate gives you a level of control that simply isn't possible with more streamlined plug-and-play setups. You're not just choosing resolutions and frame rates, you're deciding how the camera behaves at a deeper level. This is a setup for people who want to treat their camera less like a product and more like an instrument. And that's why Cinemate pairs so well with Cinepie's original philosophy. Nothing is hidden from you, and nothing is extracted away from you in the name of convenience. If something isn't working the way you want, you're free to change it. And that freedom cuts both ways. You can absolutely build something incredibly powerful here, but you can also build something fragile, temperamental, or extremely specific to one use case. This isn't a camera you casually reconfigure on set. It's a camera you commit to, which is why I don't think there's a single best way to build a Pi camera anymore. There's the plug and play path, there's the foundation first approach with the Eve, and then there's the deep end. And honestly, that's kind of the best part. For the first time, you're not choosing what camera you're gonna use. You're gonna choose what kind of camera you wanna build, what kind of camera you wanna see in the world. That's why I recommend Cinemate. Not because it is easy, but because it lets you see just how deep the rabbit hole goes. If you're even remotely interested in development or understanding how camera pipelines actually work, this is one of the best projects you could start with. And the goal isn't that everyone has to build their own features forever. The goal is that eventually we won't have to. That we collectively build something better. A platform shaped by people who actually use these cameras. I'm gonna be covering Cinemate in its own dedicated video, as well as the Eve project, so if that sounds interesting, get subscribed and hit the bell. I'll also be doing a full breakdown on my own build and exactly how I put it together. And if you want to support the channel, I've got my Amazon link in the description. And if you pick up anything to build your own camera through the link, I get a small kickback, and I genuinely appreciate it. Thanks for watching. If you want to see more, I also did a video on a $10,000 pro video setup from 2007. It was equal parts fun and frustrating to make, and I'd love for more people to see it. Anyways, that's my time, and welcome to Alt Frames.